I can be a real pedant, single-minded, and to be honest, quite boring at times, but I keep banging on about the design of these things, because everybody keeps saying, yeah, what's the power output? And in order to get that, what you really need to be able to do is measure the torque on this shaft that's being produced by the wind acting on it. Because the air density, the volume it encompasses, and the speed of that wind is what's going to determine the force that's actually trying to push that blade around. And that can be calculated just by taking a wind speed measure and working out the size of this thing. Now, when we translate that force into a rotation of the blade, whether it's horizontal or vertical like this one, then we will get some force acting on this axle here. The efficiency of that is going to be the relationship between the force acting on it and the force that is produced at the axle there. So what we really need to do is to find some way of measuring the force at that point so that we can compare those two and give ourselves an efficiency of that. It'll also help us calculate the power, because remember, if we want the power of this, we multiply the rotational speed by the force of the axle, and that gives the power the thing is actually putting out. Whether that power translates into electrical generation or not is an entirely different question. When we want to assess how that's going, then that's what we really need to do. Now, of course, there are ways of measuring rotational force on that, and it's a dynamometer. And there's several kinds of dynamometer, and if you pay a couple of £100, you can get some very nice ones that will get you some awesome measurements. But of course, we do quite a lot of things on a shoestring. So there's a particular kind of dynamometer called an absorption dynamometer, which was invented by blah Prony. I think it's Guistard de Prony, something like that. Anyway, it was in the 1800s. And he invented this way of calculating what that turning force was going to be, and it was called a Prony brake. Now, in its simplest form, this is what a Prony brake looks like. Now, it's basically a couple of wooden blocks. You connect them to a lever and add a counterweight to counteract the weight of the lever. On the other end of the lever, you add a weight, and we're going to vary that weight. Now, there are a couple of stops normally added just to stop the thing falling over. To hold the blocks together, we need a nut and a spring. And of course, we need that on both sides, because those are the bits we're going to tighten down. The springs just maintain the pressure on the lever. Now, the thing that we want to measure, the pulley or the shaft, goes in between the wooden blocks, as you can see it here. Now, it's the turning force on that pulley that we're actually wanting to measure. Now, if we just turn that on, say animation on, so you can see it rotating. Now, when the pulley rotates, the wooden block is pulled down as we increase that weight. And you keep that happening until the wheel has stopped turning. Now, the amount of weight that you put on there is actually equal to the turning force, or if you like, the power absorbed by the blocks. And you can calculate the power of the wheel on the information that's given there. So this is called an absorption type dynamometer, or a Prony brake. Now, of course, we don't have to build a Prony brake exactly like that. That's just to illustrate the principle of what's happening. Quite common is to put a rotational drum onto the shaft that's turning and then put a band, either, in fact, rope or string or leather, around that drum, and if you pull two springs, or if you like two spring balancers against that rope, you'll get a force measurement where you can actually work out, see the force that is required to stop that from turning. And that force is going to give you the power, because the power is 2 pi times the center line of the drum that you've put on there to the point at which you measure the force, times the RPM, times that number in newtons that you read off the two spring balancers, and that will give you what the power is on that rotor. So by building something as simple as a Prony brake, or using a couple of spring balancers and a strap of leather and a drum, you can actually construct a machine that is going to give you the turning force on that drum for a given wind speed. Now, we've just talked about the theory of it. Here, what we next need to do, obviously, is build a Prony brake.